All right, good morning. Today we're going to find missing sides of right triangles using Pythagorean Theorem, but we're going to leave our answers as exact answers, which you might recall means leaving your answer in simplest radical form. So open to your vocabulary, and you're going to put in Pythagorean Theorem. A squared plus b squared equals c squared if a and b are the legs and c is the hypotenuse of the right triangle. So at this point, you should have watched those animations online that showed you why Pythagorean theorem works with right triangles. And remember, c is the hypotenuse, which is the longest side of the right triangle. All right, so let's look at some examples. So use the Pythagorean theorem to find the length of the missing side in each triangle. So in this first one, we know the hypotenuse, so the legs are the other two sides. So we have a squared plus 12 squared equals 13 squared. So then a squared plus 144 equals 169. And then we're going to get a squared by itself. So we have a squared equals 25. And then you take the square root of both sides. Now, in algebra, technically, you would take the plus or minus square root of both sides. But since this is geometry, only the positive answer makes sense. So just the positive square root of both sides is fine, and a equals 5. So in that case, your answer came out to an integer. In many cases, you're going to see that the answer comes out to an irrational number. So let's look at number 10. So we have, in this case, the hypotenuse is the missing side. So we have a squared plus b squared equals c squared. 10 squared is 100. 15 squared is 225. And now let's combine the constants. 325 equals c squared. Then we take the square root of both sides. So c equals the square root of 325. And now at this point, if you type that in the calculator, you're going to get a decimal approximation, which in many cases, that's what we want. But for now, we're going to keep everything in exact irrational form. So now let's break up 325. So we have 25 times 13. So that's the square root of 25 times the square root of 13. And square root of 25 is 5. 5 times the square root of 13 is your answer. Okay, now we'll go to number 11. So this time we don't know one of the legs, so we could call it A or B. So we have 3 radical 2 squared plus b squared equals 5 squared. 3 times the square root of 2 times 3 times the square root of 2 is 9 times 4. 9 times 2 is 18. Plus b squared equals 25. And then minus 18 to both sides. B squared equals 7. Take the square root of both sides. And then that is a prime number, so there's no perfect square to factor out. So square root of 7 is correct. Okay. Go ahead, pause the video, try numbers 12, 13, and 14. Okay, so we have 2 radical 3 squared plus b squared equals square root of 21 squared. So that gives you 12 plus b squared equals 21 minus 12 to both sides is 9. Take the square root of both sides, b equals 3. Number 13, we have a squared plus 24 squared equals 26 squared. And then 24 squared is 576. 26 squared is 676. Subtract 576 to both sides. A will be 10. And then number 14, square root of 19 squared plus 3 squared equals c squared. 19 plus 9 equals c squared. 28 equals c squared. Take the square root of both sides. Square root of 28. And then let's put that into simplest radical form. So that would be the square root of 4 times the square root of 7. And the square root of 4 is 2. So 2 times the square root of 7 is your answer. And we have 3 more problems here. Pause the video, give these a try. Okay, so we have 8 squared plus 8 squared, it's isosceles, equals x squared. 64 plus 64 equals x squared. 64 plus 64 is 128. Take the square root. So that would be 64 times 2. So square root of 64 times the square root of 2. Square root of 64 is 8, so 8 times the square root of 2 equals x. And you could always use the other method to simplify radicals if you like, using the factor trees. Number 16 is isosceles because of the Bate theorem, converse. And therefore we can use half of this isosceles triangle to set up Pythagorean theorem. So that's 4 plus x squared equals 49. Subtract 4 to both sides. X squared equals 45. And then square root. So square root of 45. And then let's find a factor that's a perfect square. 9. So square root of 9 times the square root of 5. Square root of 9 is 3, so 3 times the square root of 5 is the correct answer. And then we'll finish with 17x squared plus x squared equals 12 squared. X squared plus x squared is 2x squared by combining like terms equals 144. Isolate the x squared by dividing by 2 on both sides. X squared equals 72. Go ahead and take the square root of both sides. And now we're looking for factors for 72. Let's take out a 9. So x equals square root of 9 times the square root of 8. Square root of 9 is 3. 3 radical 8. Oh, that simplifies one more step because the square root of 8 has a 4 as a factor. So we have 3 square root of 4 times the square root of 2, which will give you 3 times 2 is 6, radical 2. There you go. So go on to Delta Math and complete your Pythagorean Theorem assignment there. And have a great day. Email me if you have any questions.